All right, so let's talk about translations. This is what your equation will look like whenever it goes down. Sorry, it'll be a minus sign. And if it goes up, you will have a plus sign on the end. So guys, what is the parent function here? What is this called? I heard someone whisper it. It's a quadratic. And the equation, the parent function, is when it is an x squared. Okay? So if it goes up, let's say it went up 2 spaces. That means your equation looks like this, x squared plus 2, because it went up 2 spaces. Okay? Say it went down 3 spaces, your equation would be x squared minus 3, since it went down 3 spaces. Okay, so you'll have a number on the back of your function. Okay, so this is what it will look like. Let's see if it's translated left or right. Whenever you do any type of horizontal movement, it'll be inside of the parentheses. So if it went to the left, inside of the parentheses, you'll have a plus sign. And if it went to the right, you will have a minus sign. It looks opposite inside of those parentheses. So for example, your equation here, let's pretend that it went to the right 3 spaces. If it goes to the right 3 spaces, your equation would look like this. F of x equals x minus 3 squared. It is inside of the parentheses whenever you do horizontal movement. If it went to the left 2 spaces, so if it went left 2, your equation would look like this. X plus 2 squared, because it's a quadratic, that U shape. Okay? All right, so this is a review of how translations look like. Let's talk about reflections. Guys, what's the parent function for these graphs? What is it? Yes, square root. This is a square root graph. So if there's a reflection across the x-axis, so this is the x-axis, notice it's a mirror image across the x-axis. So this means you have a negative in the very front. So in this case, this graph down here, this is the equation f of x equals negative square root x. There's a negative in the very front. That means it's reflecting across the x-axis. Now, if your negative is inside, like this, it will reflect across the y-axis. So the formula for this would be f of negative x. If your negative is on the inside, like this equation, it's a reflection in the y-axis. Okay? Next, let's look at dilations, stretches and compresses. So right now, compressions. So now let's look at vertical dilations. So this is our function. If you have a number in the very front, this will be a compression if this value is less than 1. And we're doing the absolute value, so we're talking about positive numbers here. And then it will be a stretch if this value is greater than 1. So we'll have a times f of x. If this a value is greater than 1, it is a stretch. So the function will compress or stretch vertically by a factor of a. So let me give you an example. Let's say I have f of x equals 3x squared. Oh, sorry, 1/3 x squared. This is a compression. 1/3 is less than 1. So this will be a vertical compression. An example of a stretch is if you have something like this, 3x squared. 3 is greater than 1, so that's a vertical stretch. Okay? All right, let's look at the next one, horizontal. Horizontal compression, this is the opposite, okay? So we'll have a time, actually we'll use the letter B. I'll use the letter B. This time it's on the inside. Whenever you're doing something that's horizontal, it's going to be inside of the parentheses, okay? So if B is greater than 1, we're going to call this a compression. It's opposite. It's opposite from vertical compressions. Okay, same thing. If the number is inside of the parentheses, if B is less than 1, it's a horizontal stretch. Okay, so this is an example right here of a horizontal stretch. If it's inside of the parentheses, that's a horizontal stretch. The one on the inside, this is a horizontal compress if it's on the inside. Okay. All right. And the function will compress or stretch horizontally by a factor of 1 over A. I'm sorry, 1 over B. We're using B's right here. So it's the reciprocal. So let me give you an example really quick. Let's say I have a function f of x equals 1/5 x squared. We would call this a horizontal stretch because 1/5 is less than 1. And we'll say by 5. You basically flip it. You do the reciprocal. Okay, an example of a compression. Let's say I have 2x squared. This is a horizontal compression by a factor of 1/2. You flip what's on the inside. Okay, that's what this means down here. So these are our notes on transformations. You guys already did this one, so good job. I'm going to go ahead and put this on the board. I walked around and most of you guys had this done perfectly. So guys, what does this negative in the front do? Yep, y'all got it. Reflect over the x-axis. And what does this do? Yes, right 1. And this will be up 7. So I can already go ahead and plot my vertex. I went right 1, up 7. So right 1, up 7. 1, 2, 3, 4, 5, 6, 7. That is my vertex. So I know my vertex is at 1, 7. And guys, what is the parent function? Yep, absolute value of x. Okay, so guys, my slope is -1. You can imagine, let me erase this, clean it up some. You can imagine a -1 right here. That's my slope. So I'm going to go down 1 over 1, down 1 over 1. I'm creating a V shape, down 1 over 1. Okay, so that's my graph. We're not going to talk about odd or even just yet. We will learn that a few days from now. Okay, so just skip that part. Of course, I do not have any horizontal or vertical asymptotes, not with absolute value graphs. Okay, now my domain, I'm going forever to the left, so -infinity, and forever to the right, so positive infinity. When you're reading the domain, you always read from the left side to the right side. For the range, you look at the bottom of the graph to the top of the graph. Okay, so what is the bottom pointing to? Yep, it's pointing down to -infinity. And what about the very top? Top is up here at 7. It does not go past 7. All right, so that is how we do number 1. I walked around. A lot of you guys already did number 2 and number 3. Great job. I'm going to pause here. You guys are going to continue practicing them. All right, the way I want you guys to think about square root problems, whenever you see any type of square root problems, think about the square roots that you already know, okay? Let's start with just the square root of 0. What is the square root of 0? 0. Square root of 1 is just 1. The square root of 4 is just 2. Okay, so let's think about these values. This will help us plot this graph. Okay, so what can I put under the square root to get square root of 0? 3. So if I plug in a 3, I'll get the square root of 0. Everyone follow? Okay, so let's make a table. I'm going to plug in a 3. Because when I put a 3 right here, 3 minus 3 is 0, so I get square root of 0 plus 1. Square root of 0 plus 1 is just 1. So that's 1 point that I know that is on my graph. Does that make sense? Okay, so we got the first square root of 0. What can I plug in to get the square root of 1? What can I plug in? Yes, I can plug in a 2. So if I plug in a 2, I'm going to plug in a 2. What's 3 minus 2? 1. And do we know the square root of 1? It's just 1, and 1 plus 1 is 2. So I get that point. Okay, so we found the square root of 1. That works. Now let's try to get the square root of 4. What should I plug in right here to get a 4? I heard someone say it, negative 1. So guys, look, if I put a negative 1 right here, these two negatives make a positive. So I'll get the square root of 4. The square root of 4 is 2, and 2 plus 1 is 3. So I plugged in a negative 1, and I got out 3. Okay, so let's start plotting these points. I have 3, 1, which is here. I have 2, 2, which is here. And I have negative 1, 3, which is here. It's going to continue going this way. Okay? Okay. Just a question. Just a question. You don't have to write this down, just a question. What would happen if I plugged in a 4? What would this be? Square root, what would be under here? We don't want negatives. So guys, the graph starts right here at 3. If you plug in a 3, you get 0. And it works for numbers below 3. Your graph will be going that direction to the left. Okay? All right, so now that y'all have the graph, you guys can answer these questions. Remember, we're not doing odd and even yet. Also, I want y'all to talk about end behavior. We talked about end behavior last class. Okay, let's talk about the transformations too. I know based off of my starting point right here, how did this graph move? It went up 1, what else? It went right 3, what else happened? Yep, it reflected over the y-axis. Now, I'm just going to do some quick algebra for you in case you're curious. This is your original problem, 3 minus x plus 1. If you wanted to put it in the orientation that you're used to, I would put the negative x here and the plus 3 there. And I would factor out a negative. So this would be negative 1 on the outside and an x minus 3. Do you guys see what I did here to go from here to here? I pulled out a negative 1. If you distribute it again, you'll get the same thing. Okay, so you're used to seeing it like this. You're used to seeing it like this. So let me highlight this for you. Here's your reflecting over the y-axis. Here's your right 3. And here's your up 1. Okay? So you might need to rearrange it in order to see the transformations in the way that you're used to seeing it. Okay? Also, graphing it would help you see it as well. All right, so I'm going to pause here. Okay, also, for end behavior, we do the limit as x approaches. What do you guys want to do? What would be logical? Yes, negative infinity, because my graph is pointing to the left. It's going this way. So let's see the limit as it goes to negative infinity. So guys, as I travel to the left, what's happening to my y values? Yep, they're going up. So this will be infinity. Does my graph go off to the positive infinity side? The x values? No, so that's it. Now, in calculus, I'll tell you this part. In calculus, you'll also do the limit as x approaches this point right here, the starting point. So guys, if you follow the line, as x goes to this point, as it goes to the x value 3, What is the y value approaching? 1. That's calculus. Yes. You okay with losing bonus points? All right. What did y'all get for domain and range? Bracket or parenthesis?
Oh, yeah.
Bracket. Okay, and your range, where's the very bottom at? Where's the bottom of this graph? 1. And then it goes up from there. And of course, there's no asymptotes for a square root graph. Your parent function was f of x equals the square root of x. Then we did all of these transformations to it to make it look like what I drew. All right, nice. All right, this was number 2. Now, I wanted you guys to see that your origin, you have a point at the origin. This is your vertex because it didn't move left or right. All you have here is what type of stretch? Horizontal stretch. I'm just going to put. It was a horizontal stretch by 4. That was your only transformation. Now, if you make a table, when you plug in 0, you get 0. If you plug in a 4, you get 1. And if you plug in an 8, you get 4. Okay? So it's going to go like this. And since this is a quadratic, the parent function is a quadratic, you know that this side will also mirror. And it'll be wide like that. Okay? So that's what your graph should look like. These were the points you should have done. And if you add more points, you can also do -4. That will give you 1, and -8 will give you 4. If you plug those numbers in, you'll see. All right, I'm going to end it here.